Hello?
Hello.
Mm-hmm.
Hey, Professor, it's Karan here.
Yeah,
Hey, is anyone else in the call?
I don't see anyone.
I think like a few people from discussion were about to come, so they might come in like 10 minutes.
All right.
Hey, I was wondering, like, do you remember like when you took our discussion class last week?
Yeah,
You know how like you gave us that like you made a problem on the spot and
yeah,
it like followed the same steps that the quiz followed.
yeah.
Can you like make another one? Because today like discussion was like just three. Wait, sorry, one sec. Wait, hello.
Uh-huh.
Sorry about that. I was just walking through a crowded area. Yeah, so I was saying, would you be able to like make up another question right now, like similar to that, like that sort of thing?
Um, okay. So let's see. Um, so the quiz tomorrow will mainly be on rotational motion.
Okay.
Okay, so um, you just have to practice those problems. So let's do a couple. Um, okay, so let's say that you have. Can you see my writing?
Well, I can see you. Yeah.
You can see me or my writing?
You haven't written anything, have you?
Huh?
You haven't written anything yet, right?
Okay, I'm writing now.
It's like slightly off the camera, so yeah, I can see it.
Let me see. Okay, so it's basically what's called a conical pendulum. Okay, so there is a string and there is a mass attached to the end, and it's moving in a horizontal circle, and the
O-
angle is theta.
Okay.
All right, so let's say that the velocity, so this radius is r. So
Okay.
suppose you know theta and you know r, find the velocity with which it must be moving.
Uh.
Is it
Okay.
sharp enough? For some reason it looks like a
It
little.
like it keeps going on and off, but I can like I can make out what you're writing. It's fine.
Let me check 1 second. Okay, can you make out?
Yeah, that's perfect. Yeah.
Okay, so there is a mass m that is rotating in horizontal circle,
Okay.
and the distance from the center line is r, and the angle that it makes is theta. So
Okay.
find the velocity with which the mass has to be rotating to get this angle.
Is that the only bit of information we're given?
And here's
Yeah.
the
So
length.
with L, if you're given L, then you can then you can calculate what R is. But like, okay, this is the same as 13C in the homework, right?
Yeah, I mean, well, okay. I mean, I don't think you need to be given all this stuff. So, yeah, just try solving it. Just draw the free body diagram and see what happens.
Okay. Um.
In the meanwhile, I'll pick another problem.
uh, I'll show you my free body diagram. Okay. Oh, okay. Is this correct?
Let me check.
So I don't know if you can see it.
T. What is this mv squared over r?
The centripetal force.
There is no centripetal force. Don't draw those forces.
Oh, okay.
That's not a real force. So take
Oh,
it
that's
out.
taken from the component of T, right?
Huh?
So that would be taken from the component of T.
It would, but then don't put it in there in your free body diagram. It'll just confuse you when you're writing your equations.
Yeah.
Knock it
Okay.
out. Take it out.
So let me retry that.
So just draw the forces which are actually on the object.
Okay. So then this is what, T cosine theta T sine theta. So that's more like it, right?
Yep.
Okay.
Now write out the equations.
Uh, it's on the way up and down. So T cos theta minus mg equals 0.
I don't see your equation. T
Uh,
cosine theta, correct.
okay. And then in the horizontal, T sine theta equals mv squared over r.
Right.
Okay.
So
And
then
then
what's the velocity?
okay, then you can just solve for T from the top equation, plug it in, and get
Yeah.
v squared, right?
Yeah.
Okay, cool.
So it's pretty simple. Okay,
Yeah.
so let's do another one then. Give me 1 second.
Yeah, sure, no worries. I'll remember to bring that book for you tomorrow.
Okay. So here there is a cone, and there is a mass that is here, and it's at 300 millimeters away. This angle is 45.
Sorry, what is it again?
So this is a cone like this,
Oh, a
and,
cone. Okay, cool. Yeah, okay.
and this is it's spinning with angular velocity omega. Okay, and the coefficient of friction here is mu s is 0.2. So the question is, find the maximum angular velocity without which would not cause this block to slide. What's
So,
the minimum and maximum angular velocity that would prevent this block from sliding?
okay, so the entire thing is rotating, huh?
Yeah, this whole thing is rotating and the block is sitting
Oh,
there.
okay. Oh, okay, I see. Okay, so let's try drawing free body for the block. I'll show you my free body. Right, for some reason, like, oh, there. Okay, so for the block, you have um, you have mg going down, and then you have a normal force this way.
Yeah.
Is that it?
Friction.
Oh, of course. Sorry, but like, how would I draw it in this case? Like friction going upwards?
Well, I mean, it's
It doesn't
asking you the
matter.
minimum and the maximum. So what would happen if you are going very, very slowly, or if it is at rest? What would happen to the block?
It would slide downwards.
Okay, so then in that case, what direction must the friction be? Correct.
Oh,
Okay.
so there's two scenarios. One where friction is that way, one where it's the other way.
Yeah.
Okay, so let's draw that real quick. Oh, okay, I see. Okay, so there's two.
Uh-huh. So do them separately.
Okay, so which way would I want to? Which way would I want to resolve the forces? Like, should I just make my axis the F and the N?
What? Which direction is the centripetal acceleration in?
I don't know, like counterclockwise.
No, but which direction? Is it in the? Is it
Oh,
horizontal, vertical, along the plane? Right.
this way.
So if it is like that, then it is easiest
So
to resolve
I'll
forces in that direction.
resolve that way.
Yeah.
So okay, when I resolve in that direction, then mg is already pointing down. Okay, so mg is already pointing down. Then this is n cosine. Do we have the angle? Oh yeah, we do.
Yeah,
45, right?
45. Mm-hmm.
Nice. N cos theta and sine theta. Um, so that's what I have so far. And then you've resolved friction, right?
Yeah.
Um,
Karan, keep working. I'll be back in a couple of minutes. Okay.
yeah, sure.
Just keep doing it.
Uh-huh.
Okay. How far are you?
I've got two equations. To show you in a second.
Yeah.
But these two. Can you see them?
Yeah. But okay, so I mean, because it's go back. Oh, sorry. Oh, no, that's okay. Okay. Um, well, okay. So because it is 45, it makes no difference here. But if it's not 45, then you have it. You have sine, sine, cosine,
Yeah,
cosine.
yeah, yeah. No, yeah, I got that. That's why I just made it 45. That's why I wrote it down.
Yeah. Otherwise, it would be wrong. Okay.
Yeah, yeah, of course.
Okay.
Then
That's
it would be 90 minus theta.
yeah. It would. One of them would be cosine and one of them would be sine.
Yeah, or like 90 minus, same thing. But yeah.
Yeah. Okay. And then you're missing one more equation. What's the other equation?
Wait, I am.
Yeah, because it is just it is you're trying to find the minimum amount of what's that? The minimum angular velocity.
Oh, so it's got something to do with the rotational motion, right?
So the minimum
Or
meaning that the block would be just about to move down.
wait, it just about to be moved down.
So what is the
Well, I
limit?
don't know.
No. So what is the maximum amount of friction force that can be supplied?
Mu n.
Yeah. So you're missing that other equation, that equation too.
Oh, just that's it. Okay.
Yeah, because you have three unknowns here, N, F, and V.
Oh yeah. Okay. No. Okay. I knew that. Okay.
So you need one more.
I didn't think you write that down. That's why.
Yeah.
Yeah. Okay.
Okay.
That's cool.
So now we can solve that, right?
Yeah. If we're given the amount. Yeah. Okay.
So that gives you the minimum amount of the minimum angular velocity. And
Yeah.
likewise, if you use the other one, you'll get the maximum angular velocity. The other,
Okay. So with the maximum, the only difference would be that the f's would change, right?
yeah, the friction force would be going down instead of up.
Yeah. Okay. That's cool. That's fine. Just one second. I'm just gonna write down the problem so when I look over it again, I know what to do.
Okay.
So in this we're looking to find the velocity, right?
Yeah.
Okay, got it. Yes, and then you can just do like V over R.
Mm-hmm. Right.
But what's R?
That's 300. I think I told you it's 300.
Oh, sorry. Okay, I didn't hear. Okay. Oh, I can't read that. Sorry. No, no worries. Okay, that's cool. Thanks.
Okay.
Yeah. Yeah. Okay, got it.
Okay. Ready for another one?
Yep.
All right. So here is the problem. There is a rod, and then there is a collar on the rod. Actually, no. Sorry. This whole thing is one structure, and then there is a collar on this, which can slide. The collar can slide, and then there is spring here,
Uh-huh.
Newton per meter. This thing here is 300 millimeters,
Mm. Yeah.
and this distance is r. And you're told that this whole thing rotates. Omega is 6 radians per second. The mass of the collar is 6 kilograms,
Okay.
and the unstretched length of the spring is 400 millimeters. The question
Okay.
is, what is this position? How far does it slide?
When it starts rotating.
I mean, it's rotating at 6 radians per second here.
Oh, it's already rotating. Okay.
Yeah, it's rotating. So the question is, at what point is this stable?
Oh, okay. Would you mind
And
like
it's
focusing
frictionless. So,
would
huh?
you like to focus your camera? I can't see any of your numbers.
Let me see. How's that?
Yeah, amazing. Like that's really clear. Should I screenshot? Okay. Um. So first free body diagram of the what do you call it? The thing that
Color.
color. Sorry, yeah.
That thing.
So sorry, I don't know if you can see. MG.
Mhm.
Should we you said assume frictionless?
Yeah.
Okay. That's a spring. Well, it's just like another F. And is that all you'd include for now?
N.
Oh, of course. And wait, that's it, right?
Yeah.
Okay. Um, so in this case, to resolve, you have mg plus f. Wait, are we given some sort of angle?
Yeah. You're given. Well, you're given this is 300.
Yeah. But we're not given any other length, right?
No.
Like, so we can't calculate angle from one, right?
No.
So should we leave it as theta?
Figure it out.
Figure out the angle. Wait, right now it's stretched, right? Or no?
Yeah, it's stretched. I mean, the unstretched length is 400.
Okay, so so if we need which angle would we get? You'd get this angle. That's a lie. You'd get this angle.
I'm sorry, I cannot see your work.
Oh, sorry. You get the angle over here. Oh, sorry.
Uh-huh.
And that, let's say theta equals what is it? It's so it's inverse sine 300 over 400 plus x.
See what? What's x?
The extension.
300 over 400 plus x. Okay.
Okay. So is that's what you were looking for?
No, I'm not looking. Yeah, that x is what. No, I'm not looking for x. I'm looking for r. I'm looking for this distance.
Oh shit. Okay, sorry. Then you're just gonna do what tan reducing over r. That's it. That's it, right?
Okay.
Then wait. Then what? Well, then let's just try making f cos theta equals mg. Sorry. So you have one equation, then f
mg
sine.
plus f cosine theta n. Wait, what? mg plus f
Oh, no,
cosine
sorry,
theta
sorry.
n.
I did not mean that. Equals
n.
n. Yeah. F sine theta equals mv squared over r.
Yeah.
Okay. I don't really know what to do from here. So we're given v, we're given
Uh-huh.
r, and are we? Yeah, we're given m.
What don't you know?
Are we given the f and
Well,
theta? But
it's a spring. So what is the force of a spring?
kx.
Yeah.
Okay. Okay. But we still don't know x.
No, you don't.
So should we leave it in terms of x?
So the spring force is k times x. Now, what is the if this is so is there a relationship between theta and all that stuff, theta 300 and all that?
Well, oh, but
From
between
the
theta and
geometry, can you do something?
um between x and what else and hmm yeah.
What is it?
So you can get um if
I can see
we
your work.
Yeah, I'm just trying to draw it again. One sec. It's kind of hard. Okay. So you have this is kx. This is mg. If we say this is alpha, sorry, I'm moving closer. Then that's what cos alpha equals mg over kx.
Wait, what?
So sine theta equals mg over kx.
No, no, no. I mean that's not there's no that's not a relationship.
What do you mean?
That's not a relation. I mean the forces are not related by that angle.
Okay.
It's not. I mean, yeah, you cannot do geometry based on those forces.
Oh, okay. Then I don't really know what to do.
Well, you do. Look, okay. See, this is 300.
Yeah.
This is r.
Mm-hmm.
So what is this length?
Root r squared plus 300 squared.
Correct. And what is its unstretched? So what is its unstretched length?
Uh, what have you said? 400.
Okay, so that minus this would give you the extension of the spring, right?
Wait, that minus what? Sorry.
This length
Yeah.
minus 400 would give you the
Yeah.
extension,
Yeah.
and that extension times k would give you the force.
Yeah.
So you have the force in terms of r.
Yeah. Okay. That's it. Yeah. Okay. So that's what we want, right?
Yeah.
Okay. Oh yeah, I get that. I was looking at something else for some reason. Like I said that. Okay, it's fine. So 400 plus x squared equals r squared plus 300 squared. So you get
Show me your work once you're done, okay? I cannot see it.
this.
Okay, that's fine. Okay. Uh-huh.
Okay, and then
Make sure that you're converting into the right units, because
uh
it should be r squared plus 0.3 or something.
yeah, okay.
So you get it all in the right consistent uses
Okay,
units.
just point. Okay,
Uh-huh.
that's assuming yeah. Okay, and well, can't you just leave it in millimeters because r is gonna be in millimeters?
Yeah, but k might be in meters.
Oh, newtons per meter. Okay, I see. Yeah, I was gonna change that to millimeters. That's fine. I can just leave it. So then you get 200x equals oh no, sorry, yeah. You get so f is equal to 200.
What's 200? Oh yeah,
The
okay.
k, yeah,
Wait, what?
k
Uh-huh.
times this whole x.
Yeah, correct.
Yeah. Okay, so whatever. I assume I did that. 0.4. That's 40. That's 8. So you get f equals 200 root r squared plus 0.3 squared minus 40 times 2, 80. So you get that.
Okay. Uh-huh.
Once you have that, you can get theta, right?
What?
So once you have the force, once you have this equations, these
Kx times sine theta. What is so sine of theta now?
sine of theta is mv squared over r over kx.
No, no. But sine of theta can also be found by the same procedure.
Wait, what do you mean?
Sine of theta because of your
Oh yeah,
because
yeah,
of
yeah.
geometry.
Yes, that's like yeah, okay, I got that's cool. So you get yeah, so that's what I did before, right? 400 plus x.
Yeah,
The
but that
sine.
is in terms of tangent. You can get it in terms of sine
Oh
directly.
yeah, I put it in terms of sine first and cross it out. It's like it's there, so it's sine theta equals 300 over 400 plus x. And
No,
then we
you
have x.
already no. Don't put it in terms of 400. You already have that relationship, right? 300
Yeah,
squared plus x r squared. Bring it all in terms of what you know.
yeah. So then you're just left with root r squared plus 300 squared.
Okay. So now plug that into f times sine theta.
Okay, so then I'll do that down here. So you get um 200 root this. And then you get this.
Yeah. And
And
then
then
you can just solve for r, right? Because
yeah,
v is known, m is
v is,
known.
yeah, omega is given, so v is given, right?
Yeah.
Okay, then you can just solve for r. Okay, got it.
Got it?
Yeah. Wait, is this the kind of thing that's gonna come in the quiz tomorrow? It's pretty
This might
complex.
be a little too hard, but yeah, but I'll probably put this on your um, what's it called? Homework.
Okay.
But yeah, but that's the basic idea, you know. It's basically you have to do f is equal to ma constantly. That's it.
Okay. So what you're gonna do? Draw a free body diagram, make two equations, and then just find all the unknowns.
Exactly.
Okay, that's actually not that bad.
Okay. Let me
So
see.
you said in your email you said tomorrow's gonna be circular motion and
Gears.
gears. Yeah. Can we do like a gears question?
Yeah. Okay. Let's see.
Cause I think I get this now.
You get it right?
Well, yeah, cause that's what you said. It's like coming out tomorrow, right?
Okay. So let's see. Um. So here is pulley, and there is a gear, and it's riding on a rack. Can you see it?
Yeah, yeah.
Okay. And this is being pulled at 3 meters a second. This diameter is this radius is 0.2 meters, and this is 0.3 meters.
Okay.
So the question is, what is the speed of the rack?
What's the speed of the rack?
Yeah.
The rack's the like rectangular thing at the bottom, right?
This is the rack.
Okay. Okay. What's the speed of the rack? And the inner like the pulley you said has a 3 meters per second velocity.
Yeah. This had the cord. The cord is being pulled at 3 meters a second.
Oh, okay. And then the outer bit's a gear, so it's got the same velocity as the inside.
Sorry, what?
So velocity, right? The inside pulley.
Yeah, these two are the same velocity.
Same like okay, yeah. Well, same angular velocity, right? Or
Same
velocity.
angular velocity, correct?
Okay, cool. So first, get the angular velocity of the inside. So that's what v equals omega r.
Uh-huh.
So omega equals 3 divided by 0.2, which is 3 divided by 2/10 times 10. That's 15, right?
Uh-huh.
Seconds to my phone. So I should get a calculator, but whatever.
15 radians per second, okay.
Okay. Then That's okay, and then you can get the velocity of the outer one because the same equation, right?
Yeah.
So v of the gear equals uh what 15 times 0.3,
Uh-huh.
which is what times 10 to 10.
4.5.
Yeah,
Okay, good.
that's it.
That's it. Simple.
Oh, okay.
Yeah. So if I give you the power here, and I said that this has a power of, say, 1 kilowatt, what would be the force on the rack?
Okay, that's a bit harder. So what would I do?
And what is the torque on this? I mean, I'm not going to give you torque problems tomorrow, but what would be it?
No, it's good to know. Yeah. Okay, the torque. So torque equals I alpha.
No, when you're given
So
power,
that's
how do you find torque?
is it is it torque times angular velocity?
Yeah.
Okay, so 1 kilowatt equals torque T times omega. What are the units there? Like
For what?
for this, what units would I get for torque?
Torque. What is torque? Force times distance.
Force times distance, yeah, Newton meters.
Yeah.
But that's with kilowatts also, or no? That is what. Yeah, sorry, that's a dumb question. Um, so then yeah, then you just divide, right? So 1/15 or
Yeah.
1,000/15
Yeah.
Newton meters.
That's it.
Okay.
Newton, not Newton. Wait, 15 for 15 is the torque, correct? And what's the force?
Um, would you? Well, you have to get something in meter. Would you divide by R?
Sure.
Yeah.
Mm-hmm.
Yeah. So then it's just 1,000/15 all over 0.3.
Three newtons. What?
No, no.
What did you get for the speed of the rack?
For speed, we got 4.5 meters per second.
Okay, so then what is the force?
It's
It should be 200 something.
well, it's 1,000 divided by 15 divided by 0.3, right? I
So
can.
the torque on this gear is 1 kilowatt. So the speed of this is 3 divided by 0.2,
Yeah,
which is 15 radians per second.
yeah, that's what I got. That's what
So
last time.
15 radians per second, and then so the
Yeah,
torque is 1,000 divided by 15 Newton
that's
meter,
what I got. Yeah,
correct? And so the force
and
times
then
distance
the
is torque.
force. Yeah,
So force would be 0.3 is
for,
1,000 over
yeah,
15.
that's what I was saying.
Okay,
0.3.
so it's like something like 200 something.
I don't have a calculator. It's
Like 1,000
yeah,
divided by
yeah.
5.
It'll be like
I
200.
mean,
Yeah.
do 1,000 divided by 4, which is 250, and 1,000 divided by 5 is 200. So it's somewhere between 200 and 250.
Okay. Yeah.
Okay?
Yeah.
All right. Let's do the gear train. So here is the train problem. This is the input. Let me give you the diameter. So let's call this H, F, D, E, C, G, and A. So actually, this is the input. Sorry, input.
Mm-hmm.
And this is rotating at 40 radians per second, clockwise.
Okay.
The radius of G is 80 millimeters. Radius of C equals radius of D, which is 40 millimeters. Radius of E equals radius of H, these two,
Okay.
is 50 millimeters. And radius of F is 70 millimeters.
Okay.
Right? So find the speed ratio. That is output over input.
Okay. Sorry, one sec. No, it's phone charging. Okay. Um. Yeah. So first. So first you use the ratio between RA and RC to get the speed of RC.
Uh-huh.
So the speed of RC, it's half the size, so it's gonna be sorry, I can't read. What's the speed of A?
40.
So
40
it'll
radians
be
per second.
80.
Correct.
Okay, so I'm just gonna screenshot this question just so I have it. Okay. So RC is equal to what I say, 80 radians per second.
Uh-huh.
Uh, then sorry, one sec. Okay, then RC equals RD, so it's the same speed.
Mm-hmm.
Okay, equals RD. Um, between RD and RE, the ratio is 4 to 5. So you're gonna multiply by 4 over 5, which is, it's 80 divided by 5 is 16 times 4, 40, 64.
Okay.
So RE equals 64 radians per second. And that's the same as RH.
No.
And then
Oh, yeah.
RF.
Sorry.
Is that right?
What? I don't see
I'm
your
right so
writing.
far, yeah?
I can see your writing.
Oh, I was just talking through it. This is that, right?
RE. Uh-huh. What is RE is why is RE equal to RH?
Because you said it is.
No, I said the radius is RE and RH is 50. I didn't say the velocity is.
Oh,
Did
then
you
I
put
made
the
the same
velocity?
mistake
I'm not
before.
sure. I'm sorry. It's very jittery. I cannot see what you're writing.
Okay, no. So I'm saying, yes, let me start again. So I'm saying, first, the velocity, okay, there. Velocity at C equals 80 radians per second, right?
Correct.
Is that's the same as velocity at D, right?
Yes.
Velocity at D. Okay. And then velocity at E is equal to 64, right?
Mm-hmm.
Which is the same as velocity at H.
No.
Oh, sorry, not. Oh, okay, sorry. I just realized that. No, wait, won't it be the same at H then?
Why would it be the same as H?
Because you're gonna be multiplying the same ratio, right?
But they're not connected.
Okay, but okay,
I mean,
then
RE and RH, these two are the same. RE and RF.
wait, RE and RF are the same? Yeah,
Yeah,
okay.
because they're connected on the same shaft.
Yeah, sorry. I was being silly. I drew it like stupidly. Okay, so V equals VF, and then um, so the ratio between VF and VH is 7 over, I think 5. Yeah, 7 over 5. So times 7 over 5. So 7 over 5 equals, I'll just do the calculator. Yeah, 90.
Hmm?
90 radians per second, yeah?
Okay. Well, I mean, the procedure is right. I don't know the answer.
Yeah, it's just times 7 over 5, right?
Yeah.
Yes. Okay. So
Okay.
that's it. It's just ratios.
Yeah.
Okay, cool.
Yeah, these ratios are pretty easy.
Yeah, it's pretty sure.
Okay, anything else? I mean, that's kind of all I have.
Yeah, that's helpful. Like so, tomorrow, like, will there be just like one question relating everything?
Yeah, one or two question, one question or two questions at most.
Okay, so one on gears like this. That's gonna be
Yeah,
a ratio question,
yeah,
and the other is gonna be on like one of those force diagram questions, right?
yeah,
Cool. I'll just go over these again once more than before, and I should be fine, right?
yeah, yeah. And then the homework
Perfect.
has a lot of these problems too, right? The homework has
Yeah, yeah. No,
real
I'm
problems
gonna be
around
like
the
finished.
homework.
I'll be finishing that. Actually, there are some questions I got a bit stuck on, but now I get them, so I'll finish that really quickly.
Okay.
Yeah, and then I won't forget to bring that physics book for
Yeah,
you.
yeah, please, so that I can just assign problems from there and then for practice.
Yeah. I'm just like, so while you're here, I'm just gonna look through them really quick because I actually really don't think the problems are very good, but I'm just trying to see because like in physics, it's like we don't really do good math problems. It's like you don't draw these vectors and stuff like that.
How do you mean? I mean, that's supposed to be the point of the physics, right? That's what
Yeah,
it's
yeah, but
supposed
like in terms of it's not as hard as what we do. So I don't know if you like any of these. So I'll still give you the book in case you want
to. Yeah, okay.
to. And I don't think everyone has the book.
How come?
So like he assigned the book, but at the bookstore, that book came with a copy of this. But if someone bought it on Amazon or something, then they wouldn't have this.
Oh,
Yeah. So like not everyone, but I think like he got us a pretty good like I didn't check Amazon and how much the book cost, but he got us a pretty good deal on the book. So I'm pretty sure the majority of people got it at the bookstore.
so they have it, you think?
I'm pretty sure. Yeah. I know my roommates both have the book. Like Alex, Alex. Yeah. He bought the book. Um. And he always looks at Amazon and stuff to get other books.
Okay.
So if he bought it there, I'm pretty sure other people would have also done that.
All right, all right. Okay.
So yeah,
Yeah, that
I'll
might
bring that
that
tomorrow.
might make my life a little easier, but that's okay.
No, as in you can still use it. You can just take a photo or something.
Yeah, sure. Yeah.
Yeah, so I'll bring it to office hours then.
Yeah, please. Thanks.
Yeah, no worries, anytime.
All right?
Yeah, thanks a lot.
Yeah, no
See
problem.
you tomorrow.
See ya.